Hey guys, today we're going to continue with the quadratic formula, and we're going to feature something called the discriminant today, and we'll see what that tells us. But first we're going to start with these three equations, and we're asked for these three quadratics, how many solutions does each quadratic have? And we've only dealt with quadratics with two solutions, but to do this I'm going to go through the quadratic formula with each one, and we're going to look for a pattern to help us determine how many solutions we have. So our first one, if we use the quadratic formula, opposite of b, 7 plus or minus the square root of b squared is 49 minus 4ac. ac is 4 times 4, so minus 16, all over 2a, which is 4. So x equals 7 plus or minus the square root of 49 minus 16 is 33, all over 4. And then from here we can kind of determine that there's going to be two solutions. And that's what we're going to leave it as for now. We'll look for a pattern in a second. On to our green one. If we use quadratic formula, opposite of b is negative 10 plus or minus the square root of b squared is 100 minus 4ac. A is 1, c is 25, so 1 times 25 times 4 minus 100 all over 2a, which is over 2. So x equals negative 10 plus or minus the square root of 100 minus 100 is 0, all over 2. Now for this one, if we're thinking about how many solutions we have plus or minus the square root of 0. Square root of 0 is the same thing as 0. And if you think about it, it doesn't matter if you add 0 or subtract 0, you're going to end up with the same answer. So here you're only going to end up with one solution. And that was because your square root of 0 simplifies to 0, so you're adding or subtracting 0. It's the same thing. In our last one, we have x equal to, opposite of b, negative 2 plus or minus the square root of b squared, which is 4, minus 4ac. So a times c is 5, times 4 is 20, so minus 20, all over 2a, so all over 2. So x equals negative 2 plus or minus the square root of 4 minus 20 is negative 16, all over 2. And this one, negative 2 plus or minus the square root of negative 16, we're going to end up here having 0, and I'm going to write the word real, solutions. So we have three scenarios here. We have two solutions, one solution, or 0 real solutions. And what we can kind of use to figure that out is focusing all on these square roots. Since we have the plus or minus of the square root of 33, in one scenario you're going to add the square root of 33, one scenario you're going to subtract the square root of 33. That's why there's two solutions. For our middle one, we have plus or minus the square root of 0, but the square root of 0 is just 0. So it doesn't matter if you add or subtract 0, you're going to stay where you are. So that's why there's only one solution. This plus or minus is not really two scenarios here, because they're going to end up with the same solution. And here we have plus or minus the negative square root. And since we can't take the square root of a negative, well, you can't yet, not until you learn about imaginary numbers, we're going to have 0 real solutions here. So when it comes to determining the number of real solutions we have, it all comes down to what's underneath the radical. And we call that the discriminant. That's our discriminant. So in our formula, x equals the opposite of b plus or minus the square root of 4ac all over 2a. I'm going to write it in black. This is your discriminant. b squared minus 4ac. This, not including the radical, just the b squared minus 4ac, that tells you how many solutions you have. b squared minus 4ac. If this is a positive number, so if it's positive, then you have two real solutions. If you do the 4 or b squared minus 4ac and it equals 0, then you have one unique real solution here. And if you do the b squared minus 4ac and it's a negative, meaning you're taking the square root of a negative, then you're going to have 0 real solutions. Again, this is called the discriminant, that b squared minus 4ac. So what you're taking the square root of, that's the discriminant. And you can use this to determine how many solutions you're going to have in a quadratic. So let's look at one. This one says state the value of the discriminant and determine the number of real solutions. So we have 4x squared plus 5x equals negative 3. So in order to find the discriminant, we still need to be in the form ax squared plus bx plus c equals 0. So here we can go right to seeing the discriminant if we just want to know how many solutions we have. We don't necessarily want to know what they are. We can go ahead and say b squared minus 4ac. Well, b squared is 25 minus 4ac, so minus 4 times 3. 4 times 4 is 16 times 3 is 48. And 25 minus 48, that's going to give us a value of negative 23. So our discriminant, is capital D here, is equal to negative 23. Which means, well, that's the value. Since it's negative, we would be taking the square root of a negative, so there's 0 real solutions. Just based upon knowing that the discriminant is a negative number. All right, we're going to try one more. You can try some of these on your own. Our next one, we have the quadratic. 2x squared plus 11x plus 15 equals 0. Notice we're in the right form. We've isolated 0 on one side, ax squared plus bx plus c. That's what makes it a quadratic. So let's take our b squared minus 4ac. So b squared is 121 minus 4 times 2 times 15. 2 times 15 is 30 times 4 is 120. So our discriminant has a value of 1. That's a positive number. So that means we would have 2 real solutions. And just like that, we're all done. So that's the discriminant. It's just a little part of the quadratic formula. In your opposite of b, plus or minus the square root, it's everything underneath the square root. We'll put it in green here. This is the discriminant, the b squared minus 4ac. That tells you how many solutions you have because it's what you're taking the square root of. If it's a positive, you're going to have 2, the plus and the minus. If it's 0, adding and subtracting 0 will yield the same thing. And if it ends up being a negative underneath the radical, then you're going to have 0 real solutions. All right, that's all we got for the day, guys. Have fun.